Welcome to lesson 12.3. Today's lesson is going to continue our discussion about quadratic functions, and more specifically the shifted form of a parabola. So we know this form right here, which is the y equals ax squared plus bx plus c form. So this is standard form. Today's lesson is going to talk about how we shift this form into something called vertex form to help us find the vertex. Because standard form, it's really hard to find the vertex in standard form. So your aim today is that I can use shifted form or vertex form of a quadratic to easily find the vertex and describe how the graph changes from this basic graph of y equals x squared. Although the standard form of a parabola has its advantages for certain applications, it's not helpful locating the most important point on the parabola, the turning point. In this lesson, we're going to learn about a form of a parabola where the turning point is very obvious. First, though, let's review simple parabolas. Okay, so the directions for this says without your calculator, sketch each of the parabolas shown below on your own set of axes and state the coordinate of the turning point of both. So I'm going to draw a coordinate grid very carefully. Okay, this is my x-axis and this is my y. Alright, and now I'm going to graph both of these. So in order to graph them, I need to make a table of values because I'm not using my calculator. That's what it says to do without using your calculator. So I always like to start with negative numbers. So I'm going to do -1, 2, -1, 0, 1, and 2. This should be plenty to figure this out, to get a good graph on here. So when I plug -2 in for here, -2 squared is 4, and 4 times 2 is 8. Next one, -1 squared is 1, and 1 times 2 is 2. 0 times anything is just 0. And then going up the other way, 1 squared is 1, 1 times 2 is 2. And I know from my pattern this has to be 8 because it's going to start to repeat itself. Okay? So I'm going to plot these points, -2, 8, 1, 2, 3, 4, 5, 6, 7, 8. So here's -2, 8, -1, 2, 0, 0, and then 1, 2, and 2, 8. Okay, this gives me this graph here. Alright, now I'm going to graph the other one. I'm going to make a table and graph -3x squared. Same points I'm going to choose. I always start with a negative when I make a table because you want to include negative and positive values. So I'm going to plug in -2, and I'll show up here what I'm doing. I'm plugging in the values in for x. We've done this a lot when you make a table. You plug it in for x and then calculate. -2 squared is 4, and 4 times -3 is -12. Then I'm going to do the same thing for 1. -3 times -1 squared. -1 squared is 1, and 1 times -3 is -3. When I plug in 0, 0 squared is 0, and 0 times -3 is still 0, so I get this 0 here. Plugging in 1 squared is 1, and 1 times -3 is -3, so I can see here's where I start to repeat my values, so I know that this has to be a -12. I'm going to plot my points. -2, -12 is somewhere down here. -1, -3 is here. 0, 0 shares the same vertex with my first graph. 1, -3 is here, and 2, -12 is somewhere down here. So I have this blue graph now. Okay? So I want us to think about what these two graphs have in common. And I need to just erase this a little bit. What do these two graphs have in common? What do they share? They both share this same vertex. So this is really important to notice, that they share the vertex. And they share it because of what's happening in question C. If we have a parabola in this form, ax squared, meaning there is no bx or c, then it always will have a turning point at 0, 0, or at the origin. This is always true. Notice how there is nothing here at the end. There's nothing here. There's no plus anything at the end. That's this form, just the ax squared. No bx or c will always have a vertex at the origin. This is a really important thing to memorize and to think about because it's going to lead us into the shifting of future quadratics. So let's take a look at the next exercise and what we're going to talk about. So exercise 2 says consider the basic quadratic function f of x equals x squared. So here's our basic function. And then we're going to talk about the more complex function, this right here, this new function, g of x equals x minus 2 squared minus 4. Now this is still a quadratic because it's got the x squared, but it's not in our standard form. This is a very different form right here. Okay, this form right here, it's called the vertex or shifted form. Okay? So the graph of f of x equals x squared is shown here. So I'm going to highlight it in green because this is my f of x equals x squared. Okay, that's my green function. Letter A says, using your calculator, generate a table to sketch the graph of g. So let's get our calculator up. Okay, so I'm going to make this a little small here. Alright, so here's my calculator. Okay. And I have my calculator over here. I'm going to get a new screen to graph. Okay, I'm going to hit Control N to get a new graph. No, I don't want to save changes and I want to add graphs. So I'm thinking about, hold on a second if I can get this to come back. There we go. Okay, so here's what I'm graphing in blue, x minus 2 squared minus 4. So I'm going to type that in, parentheses, x minus 2, parentheses, squared, minus 4. I'm going to hit enter. There's my graph. It pops up, but the question is telling me to get a table. So to get that table, I'm going to hit Control T to get my table. There's my table. I do want some negative values though, so I'm going to kind of scroll up to get some negatives. So I see when I make my table. So let's come back here. Oh, let's not do it in green. Let's do it in blue. For some reason blue, there we go, there's blue. Okay, so here's my table for this function, the g of x function, sorry. Okay, so g of x equals x minus 2 squared minus 4. And over here on the right side, you can see my calculator. The first point here, negative 2, 12. Then I have negative 1, 5. Then I have 0, 0. Then I have 1, negative 3. 2, negative 4. I'm going to go over to my calculator. I'm going to scroll down. 3, negative 3. 4, 0. 5, 5, and 6, 12. So 5, 5, and 6, 12. So there's my table. And now I'm going to use my table to plot my points. I don't need my calculator anymore, so I'm going to make this full screen again so we can see it better. So I'm going to plot my points onto my table. My first point here is negative 212. That's not going to fit, so I'm not going to plot that point. It doesn't fit on my grid. But this next one will work, this negative 1, 5. So negative 1, 1, 2, 3, 4, 5. There's the first point. This next point, 0, 0, is right here. Then I have 1, negative 3. 1, 2, 3, right here. I've got 2, negative 4. So 2, negative 4. And then I can see my y values are starting to repeat themselves. So this is going to be here. And then I have 4, 0, which is right here. And my last point that I can plot is this 5, 5. So that goes right here. And I can see I have made my points that form my quadratic, and they look like this. Okay? So now we're thinking about this word about shifting. How would you need to shift the graph of f of x, which is the green graph? How are we shifting this green graph here and turning it into the blue graph is what this question is asking. Okay, and shifting, the word shift means move. How do we move the green graph to turn it into the blue graph? And moving, this word moving means moving in terms of the vertex. Okay? So here is my vertex for the green graph, and here is my vertex for the blue graph. How am I going from this point? So let's call this, f of x point, and this g of x. How do I move from f of x to g of x? Well, this is a lot like thinking of rise over run a little bit. I'm going to move 1, 2 moves to 2 units right, to the right, and I'm going to move 1, 2, 3, 4 units down. This is how it shifted. My graph went 2 units to the right and 4 units down. Okay? That's the shift. So the cool thing about shifted form is take a look at question C. Question C says, what is the turning point of g of x, and where do you see this in the equation? So I'm going to rewrite the equation. G of x equals x minus 2 squared minus 4. Do you see how in here is the 2 units we moved to the right? And here are the 2 units we moved, or sorry, not 2, but the 4 units that we moved down. So vertex form, or we call it shifted form, tells us the vertex. Oops. So the vertex for this equation is 2, negative 4. The only thing you have to remember, and this is kind of tricky, is that this becomes positive. Okay? And we're going to do a little bit more practice with this idea here. Alright, but you can see that the shift, here's the 2, here's the 4, here's the 2, here's the 4. So vertex form tells us where the graph is shifting from this original just x squared basic parabola. Okay, let's keep exploring this in exercise 3. Exercise 3 says the parabola y equals x squared is again shown in the grid below. And now consider the quadratic functions y equals x squared plus 2 and x squared minus 4. Okay, so I have my original basic function here, which I'm going to mark again in green. I'm going to highlight this in green because I like the colors. I think it shows you a little bit more. So this is our basic x squared function in green. And now we're going to look at x squared plus 2 and x squared minus 4. We're going to use our calculator to generate tables, and we're going to sketch these two things onto our graph. So I'm going to go back to my calculator, and I'm going to get these two equations onto my graph. So I need a new graph, so I don't want to save changes, add graphs. So the first one is x squared plus 2. I hit enter, and I'm going to hit Control T to get my table. Now I'm not going to write this table down, I'm just going to look at here and plot points. So I'm going to start right here at this negative 2, 6, and I'm going to start plotting points there. So I have, and I'll use, actually let's do it this way. Let's make my table here. So y equals, oops, oh what just happened? Y equals x squared plus 2, and that table is going to be here, so x, y. So I have negative 2, 6, negative 1, 3, 0, 2, 1, 3, 2, 6. Alright, now let's graph the second one. So get a new graph, no, don't save changes, add a new graph, and now we're going to do the second one. We're going to do y equals x squared minus 4 and get that table. So I'm going to plug that into my calculator. X squared minus 4 and hit enter and get my table, hit Control T, and I'm going to find my points. My points start about at negative 3, 5. So I'll start negative 3, 5. negative 2, 0, negative 1, 3, 0, negative 4, 1, 3, 2, 0, and 3, 5. Alright, so now I've made my tables on my calculator. I'm going to take these tables and plot them on my grid. Okay, so let's start with the red, x squared plus 2, and let's plot these points. So negative 2, 6, 1, 2, 3, 4, 5, 6, negative 1, 3, and 0, 2, 1, 3, and 2, 6. So I get a graph that looks like this. And now let's graph the purple, the x squared minus 4. I have negative 3, 5, 1, 2, 3, 4, 5, negative 2, 0, negative 1, 3. Oh, that should be negative 3. Negative 1, negative 3, 0, negative 4, and then the points are going to repeat themselves. 1, 3, sorry, again, negative 3. 1, negative 3, 2, 0, and 3, 5. So something very cool happens with these two graphs. You're going to notice they're all exactly the same except what is shifting. So letter B is asking us, letter B is saying, what was the effect of adding a constant to the overall function? So all we did was create this plus 2 and minus 4, and look what it did. Do you see how this has the plus 2 here? That's at the point 2. And do you see how this is at negative 4? So the effect of adding the constant was it just shifted the graph on the y-axis. It just changed the y-intercept. Okay, remember that when y equals ax squared plus bx plus c, the constant is your y-intercept. So notice that in both these cases, my y-intercept here is 2, my y-intercept here is negative 4, my constants here is 2, and my constant here is negative 4. So that's all that that shift did, was moved it to negative 2 and negative 4. Okay? Letter C says state the turning points. That's another fancy word. That's a way to say vertex of each of the parabolas you drew in A. So what's the vertex of y equals x squared plus 2? That's my red. That's right here. Well, that vertex is at 0, 2. What's my vertex on the purple? Y equals x squared minus 4. That's right here. And that's at 0, negative 4. So the vertex of an equation that does not have a bx term is going to be the constant. So in other words, when we take a look at this question right here, what would the coordinates of this turning point be? Well, it would be 0, negative 150. So when you have something that's y equals ax squared plus c, and you have no bx term, your vertex is going to be 0, c. Okay? So that's something else to think about with shifting. Okay? So finally, let's take a look at what happens when we have a number subtracted inside the parentheses. So again, we have our original shift here with y equals x squared. I'm going to highlight it in green again. It's our basic x squared function, no bx, no c. And now let's consider what happens when we add a number and subtract a number in the inside. So I have y equals x plus 3 squared, and I have y equals x minus 1 squared. Same thing, let's use our calculator to generate tables and sketch the two quadratics. So I'm going to go to my calculator. I'm going to hit Control N and get a new graph and add it in. So the first one is x parentheses x plus 3 parentheses squared. Okay, no c term now. I'm going to hit Enter, and I'm going to get my table, Control T. So I'm not going to copy the table onto the notes. I'm just going to scroll up to where I can see points, and I'm going to plot those points. So the first point that I can plot is this one right here, this negative 5, 4. So negative 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. So that's the first point is right here. The next point is negative 4, 1. So negative 4, 1. The next point's negative 3, 0. Then I have here at negative 2, 0 and negative 1, 5. So I have my red graph right here. Okay, now let's do the purple. I'm going to get a new graph. And now I'm going to plug in y equals x minus 1 squared. So parentheses x minus 1 parentheses squared. I'm going to hit enter. There's my graph. Hit Control T to get my table. And now I can start plotting my points on this purple graph. So I'm going to scroll up to where I see points, and I'm going to start here at negative 1, 4 because this 9 I don't have room to fit. So negative 1, 4 is 1, 2, 3, 4. It's right here. Overlaps with that point. 0, 1 right here. Then I have 1, 0. Then 2, 1. If I scroll down, I'll see 2, 1. And then 3, 4. Okay, gonna connect my dots and make my graph. Now we're seeing something interesting with these two. What is happening with these two graphs? They're just shifting left and right. But why is the shift weird? Notice that when we shift to this one, this has a positive +3. But where is it actually shifting? It's actually shifting to the left. And notice here on this shift, we have a negative, but where's it actually shifting? It's shifting to the right. So that's kind of what this means by counterintuitive, is that it's actually the shift is the opposite. Okay, so when you have the y equals this something in parentheses, this x plus 3 squared, you are actually shifting to the left, the opposite way. Okay? So you do the opposite shift for what's inside the parentheses. Okay? So letter C, let's state the coordinates of these new turning points. So if I look here, what's the coordinate here? This is negative 3, 0. So negative 3, 0. And that would mean that this turning point here would be 1, 0. Okay? And now we're going to use this information to be able to find the coordinates of the turning points of these following quadratics. So, to sum up before we do this, I want to make a little note down here. Okay? This form actually has something that looks like this. X minus h squared plus k, where h comma k is your vertex. Okay, the k part of it, I'll make this purple, k determines your y coordinate. Okay, k determines your y coordinate, and this h here is your x coordinate. But what we just learned is it has to be the opposite of the x coordinate. Okay? So this right here is what you need to memorize for shifted form. Okay? And let's practice this right here for these couple of questions. So for letter D, I have x minus 8 plus 5. Okay, I'll do red here. So this right here, when I want to find my coordinate, this is my x coordinate, and the 5 is my y coordinate. So when I make my vertex is going to be a coordinate, but the x is going to be the opposite of negative 8. What's the opposite of negative 8? Positive 8. And the y coordinate stays the same at 5. Okay? This is how vertex shifted form is used. Okay? This next coordinate here, the 5 right here in front, this 5, that just tells us whether it's concave up or down. Is this a positive 5? Yes, so it's concave up. That's just like in the old lesson. This right here, this is our x coordinate at negative, oops, sorry. Is that a positive or a negative one? Oh, where's my eraser? Sorry. That's a positive one, so when I make my x coordinate, I have to make it negative. Then I'm going to take the constant at the very end, this negative 4, and that stays the same. So that's my vertex for that equation. Finally, the last one, this 2, because it's negative, means it's concave down. Right, because we talked about this before. If I have my A value in front of here, this A, XH, this tells whether it's concave up or down. Alright, then we do the vertex. Vertex is determined by the number inside. The number inside's a -3. Let's turn that into a +3. And then put the constant as my Y value. Okay? So this is something you have to memorize about the shifted form and being able to just look at the equation and see what your shift is. You can always double check your work with a calculator, but oftentimes the Regents will ask you, hey, how is it shifting from x squared? So for example, for this problem, if I start with y equals x squared and I shift into this, y equals x minus 8 squared plus 5, this is a shift of 8 units to the right and 5 units up. That would be what you'd have to talk about for your shifting. Okay, if you have questions about any of this, please come talk to me. This is a tough lesson. It's all about critical thinking and memorizing what these different formulas are. So please come to me if you need help or need clarification. Okay, and good luck on your fluency.